A tidal power. A tidal power is a generation of electrical power through the harnessing of the ebb and flow of the tides. The advantage and the disadvantage of a tidal power. The advantages. It is very cheap to maintain. There is no waste or pollution. Very reliable. We can predict when tides will be in or out. The barrage can help to reduce the damage of very high tidal surges or storms on the land. Disadvantages. It changes the coastline completely and the estuaries are flooded, so any mud flats or habitats that birds or animals live on are destroyed. Initial building cost is very expensive. Water is not replenished. It cannot flow away, so any dirt or pollution lingers around the coast much longer. Silt builds up behind the barrage. Disrupts creatures' migration in the oceans. Needs a very big piece of sea to be cost-effective. Not many sites suitable for this kind of power generation. Building the barrage only produces up power for about 10 hours of the day. What are the costs of tidal power? Tidal power is a form of flow-head hydroelectricity and uses familiar low-head hydroelectric generating equipment, such as has been in use for more than 120 years. The technology required for tidal power is well developed, and the main barrier to increased use of the tide is that of construction cost. There is a high capital cost for a tidal energy project, with possibly a 10-year construction period. Therefore, the electricity cost is very sensitive to the discount rate. The major factors in determining the cost-effectiveness of a tidal power site are the size of the barrage required and the difference in height between the high and low tide. These factors can be expressed in what is called a site's Gibbert ratio. The Gibbert ratio is the ratio of the length of the barrage in meters to the annual energy production in kilowatt hours. 1 kilowatt watt used for 1 hour. The smaller the Gibbert site's ratio, the more desirable the site. Examples of Gibbert ratios are Lawrence at 0.36, 7 at 0.87, and Pasama Cody in the Bay of Fundy at 0.92. Offshore, tidal power generators use familiar and reliable low-head hydroelectric generating equipment, conventional marine construction techniques, and standard power transmission methods. The placement of the impoundments offshore, rather than using the conventional barrage approach, eliminates environmental and economic problems that have prevented the deployment of commercial-scale tidal power plants. Electricity can be generated by water flowing both into and out of a bay. As there are no high to low tides each day, electrical generation from tidal power plants is characterized by periods of maximum generation every 12 hours with no electricity generation at the 6-hour mark in between. Alternatively, the turbines can be used as a pump to pump extra water into the basin behind the barrage during periods of low electricity demand. This water can then be released when demand of the system is greatest, thus allowing the tidal plant to function with some of the characteristics of a pumped storage hydroelectricity facility. It is renewable. Yes, the tide will continue to ebb and flow. Thus, there will always be power being generated. The water is not used up. It stays in the water cycle and can therefore be used over and over again without the need of replenishment. How does it work? A barrage, which is in fact a huge dam, is built across a river, estuary, or bay. This barrage has gates in it which allow the water to flow into the barrage with the incoming tide. These gates are then closed when the tide begins to go back out.